Let's get busy. Let's get busy. Okay. Here we go. So we're going to come back over to 48 and 24. And we are on acronym Haskell. Let's hop on in. Join the Haskell track. Okay, so let's go local and install the Haskell's tooling. Okay. For doing exercises, you only need stack. Okay. Let's hit it. GH cup. Okay, here we go. Okay. Wait a minute. Add the required path variable. Sure. Install the language server. Sounds great to me, baby. Integration of stack with GH cup. Okay. Okay, proceed, I guess. I don't know. I guess I mean, I might be missing some things. I don't know. Please, yeah. I should have aborted and checked those. Oh well. If it doesn't work, I'll just do it again. All right, cool. All right, what are we doing? Hopefully it'll work just fine. I don't know. We'll see. Hmm. Okay, so we did good. It says successful. That sounds good. That always sounds good. Okay. Package Haskell org. Okay. Oh no, what are all these? That's showing a lot. Okay. All right. Pretty sure we did get this, but shouldn't hurt, I don't think. I think it should not hurt to do this. Oh no! It modified the bash RC. Okay, let's take a look. Okay, so at the end, I see this. So I think maybe this is the same that should go into the ZSHRC. Let's see. Maybe? Okay, that's more like it. All right, so we're good there, I guess. Let's do the hello world. I think that they have, what exercism has done here is so cool, the way they've just streamlined this whole process for you. I think it's really cool. Okay, Haskell. Cool. Oh, Haskell, yep. Hello world, okay. Okay, so GHC not installed, so it's going ahead and doing that, I guess. All right, fair enough, fair enough. Yeah, pretty cool, I would say. All right. This may take a while. Oh no. Okay, well in that case, let's read up a little bit about Haskell before we do anything else. Okay, let's take a look. Set up a development environment. Okay. Quickest way is to use GHCup. Okay, we got that. Use VS Code as the editor. Cool. It's a very good editor program. Cool. All right, so GHCI. Oh no! Uh-oh. It said installation successful here. All right, so that didn't take as long as I feared. But then what happened? Error. While building simple setup.sh, or excuse me, .hs. GCC failed in phase linker. Unable to find library LGMP. Okay. Okay, so what was that? How do we... I'm trying to learn things. This one. This one gave some pretty useful. apt cache. Apt cache search. And so the one it said we were missing was LGMP, right? Oh, I didn't get anything. So what is LGMP? Okay, LGMP. Okay, so maybe it has to be libgmp. Let's take a look. Libgmp. Oh, that's better. Okay, so now we want to choose the one of these, and this person said libgmp3. Interesting. I'm just going to try both, actually. Let's do libgmp dev and libgmp3 dev, because I don't know which one it wants necessarily. They're both the same thing, right? Multi-precision arithmetic library developers tools and multi-precision arithmetic library developers tools. So I don't know. I think we can just do both. Yeah. Let's grab it, baby. Okay. So now, if we do test again, let's see if it's any better this time. I think it's better. It looks a little better, maybe. It's kind of a lot of output, though. Like, that's a little crazy. Oh, maybe this is the part that was supposed to take a while. Okay, let's see what else we have in getting started. All right, so GHCI, they put in some handy, tasty math, I guess, so that's cool. Then we did something here, take 10, filter even 43, dot, dot. Pretty cool, pretty cool. Sum it. It remembers the result of the last expression. That's nice. Sweet. I dig it, baby. I dig it. Have to try some of these out once it's done here, I guess. Okay, so then let's see. So we have a main equals do. Put string line, hello everybody. Okay, put string line. Please look at my favorite odd numbers. Show plus plus. Okay, so this is a string concatenation, I guess. And then show, I guess, turns it to a string, maybe. Filter, okay. Odd. Okay, so it showed that there's a sort of an even built in, and there is an odd built in, very convenient. 10 dot dot 20, okay, cool. And then it shows that, that's neat. What else should we know? You can load your file directly into GHCI. Oh, good, very nice. That's great. And then you can run main. Okay, wonderful. Okay, so next steps. Learn you a Haskell for Great Good book. Ah! Okay, let's take a look. Read it online. Yeah, baby. Learn you a Haskell for Great Good. If you're reading this, chances are you want to learn Haskell. Well, I mean, okay, it's done. Stack failed to execute the build plan. So, I mean, it's done, but it's not successful. Wait. Scroll up to its section to see the error. HSpec core 297. Okay, let's look. This is all HSpec core. LT info. Let's take a look at that one. Unable to find library LT info. This is probably one of the things it warned me about right from the start, and I didn't pay attention. Libt info. Okay, let's look. Apt cache search libt info. Yeah? Okay, well, that one's pretty clear. It is a transitional package for libncurses-dev. All right, well, if we need it, we need it. Oh, gosh, that's not it. Install. And we'll go libt info dev. Yeah? Yep, let me have it. Let me have it, baby. Okay, let's try again. Okay, so we're back to the HSpec core. Let's see if we finish this one this time. Come on, Haskell. Yes. Oh, no. Oh, okay, this is fine. So we got Goodbye Mars. So we're good. So now we will do the Hello World Cabal. Why is it called a cabal? Is that what it is? Hold on. No, I don't think it's the cabal. I think it's something in source. Oh my gosh. It seems like there's kind of a lot here. But I think the one we want is the source Hello World HS. Okay, source. This. Okay, so it says the wrong thing. And now it says good. So let's submit. That. Okay, so let's take a look. And processing. Okay, fair enough. Fair enough. Passed. Okay, so let's mark as complete. Okay, let's see what happens when we try this. So, the exercise is called acronym. Convert a phrase to its acronym. All right, well, it seems like a simple concept. Am I going to know how to do this in Haskell? Maybe. Okay, so let's go to acronym. Okay, so let's look at our source file. Do we have one? Okay, abbreviate. So we're going to take a string and put out some other string. You need to implement this function. Okay, so my thought, like, obviously there are several ways you could do this. Let me take a look at what I would do if it were JavaScript. So if I wanted to take any phrase and convert it to its acronym, as soon as possible becomes ASAP. Liquid Crystal Display becomes LCD. Thank George, it's Friday becomes TGIF. Okay, so what I would do is maybe say acronym equals S, and then go S match, and then match wherever there's a word break, match this next thing, and match that globally maybe. Oh, wait. Oh, you know what? I don't need that. Yeah, maybe like this. Let's see what it does. And then just literally join, and then go to locale uppercase. That's probably what I would do. And then if we go acronym for one of these as soon as possible, then I get ASAP. Oh, why do I have spaces in there? Okay, we don't want spaces. Okay, ASAP. And then let's try this one. Uh-oh, I got a dash in there. We can't have a dash. Okay, so instead of trim, I would say maybe... No, it's, maybe more like filter. Okay. Oh wait, where's as soon as possible? Okay, and then how about this one? Thank George, it's Friday. TGISF? Okay, so that won't work either. So I don't think I want a word break. I think I want a white space. Nope, 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 nope. We need that, or, oh, and this has to be a word character, or a word character at the beginning. Okay, so I mean, I can already see that, like, it's pretty simple, but I already ran into a bunch of errors and mistakes because, I don't know, because I'm kind of dumb, I guess. Okay, so then for this one, okay, so the dash, I mean, is the dash a special, is the dash a special case? And if it is, how many special cases might there be? Okay, so that's no good. I've screwed it up now, baby. Okay, no, no, no. Trim was supposed to be in here. I put okay. So those are okay now. What other cases might... So yeah, man. Ah, it should be simpler than this. Like, I've done way too much here, I think. But, okay. Well, I mean, I got those. What other cases? So let's do portable network graphics. I mean, that should be simple enough. Here, let's say liquid crystal display as soon as possible. Thank George. It's Friday. Portable network graphics. Yeah. Okay, so those are fine. What else would we add into here? Maybe something like, or they did have another example, right? It was 3-letter acronyms. What are some other edge cases? Let's Let's actually look in the test cases. Okay, so we have portable network graphics, Ruby on Rails. Let's take a look at that one. Ruby on Rails. ROR. Okay, that's fine. Hypertext. Oh, shoot. Okay, darn. Yeah, I'm not going to be able to handle that one with what I've got now. So this case was removed in specification 110. The Haskell track has chosen to keep it since it makes the problem more interesting. Okay, cool. Fair enough, fair enough. So this is wrong. HML. HML is not good. So I'm just going to handle that as another special case, I guess. For now, I mean, I don't know. So this is a case where we want let's see. So are we, wait. So I don't think we want any capital letter because what if, is there one where it's in all caps? Okay, so there's not a shouty case example here. Oh wait, yes there is, GNU. Okay, so it's not any capital letter. It's a capital letter that follows a lowercase letter, right? So we have an A through Z followed by an A through Z. But we have to drop the lowercase letter in this case. So if we have two letters, we're going to keep only the second, I think. So like that. Then we'll keep only $2, I think. I think I messed that up. Okay. LCD, TLA. Okay, so $2 ended up as a number 2 because I think I've forgotten. Oh, wait. Is it $1? I think I've forgotten how you actually reference that match group. Oh no, that's fine. HTML. Okay, so LCD, TLA, ROR, HTML, ASAP, TGIF, portable network graphics. Okay. How about first in, first out with a comma? I think the comma shouldn't matter, but let's see. Okay, that one's fine. Okay, so GNU image manipulation program. Let's take a look. Okay, that's fine. How about CMOS? Let's take a look. Okay, that one's good. Then rolling on the floor laughing so hard that my dogs came over and licked me? Well, I guess that's fine. Let me put that on its own line. ROTFL SHTMDCOALM. Okay, that's fine. Okay, something I made up from thin air. Okay. SimUfta. Okay, that's fine. Halley's Comet. Whoops. HC. Okay. The road not taken. What's this one gonna do? This one might underscore emphasis. This one might screw me up. I think it will actually. Let's see. That one should be TRNT, but I got TR underscore T. Ah, that's very bad. So we don't want that. So let's see. $1. Yeah, we definitely do not want an underscore. So if it's this, yeah, that underscore should not count there. It should be A through Z, A through Z. And then here, this could be a dash, or it could also be an underscore. All right, so LCD, FIFO, GIMP, CMOS, TLA, ROR, HTML, TRNT, that's right? ASAP, CMUFTA, HC, TGIF, I don't know, and ping. Okay, great. So, interesting. So, I mean, this seems like, honestly, this seems like kind of a lot. Like, all these different special cases or whatever. And now my question is, how do I make it work in Haskell? So, my first thought is like this regex and this regex and this regex. These are and this one. So I guess I've got 4 different regexps, and they're doing a lot of the work. So if I can use these same regexps in Haskell, then they'll do a lot of the work, and I just have to figure out how to do that. Okay, so let's see. Haskell regex. Let's take a look. Okay, so regular expression library for Haskell. Are we going to be able to use this though? Because it seems like it's like is it like a separate library package that has to be installed? I don't know. Hmm. Wow. Uh, okay. Um, this is fine, I guess. I don't. Okay, so you can import text regex base, and then you have to choose one of the back ends, I guess. Okay. Okay. I've got to think this over. Okay. So this exercise, should read about string types in Haskell. Oh, that sounds useful. Let's take a look. It's not loading. Okay, import data text. Okay, wait, hold up. Add text to your list of dependencies. Import data text in the following way. And you can now write abbreviate text to text and refer to data text combinators. This part is entirely optional. Huh. Okay. So this one timed out. We were looking for a Haskell tutorial on string types. Haskell tutorial string types. Is it there? I don't know what it is. Oh, a cheat sheet. It's just a list of characters. Okay, fun. Okay. Time and space efficient implementation of Unicode text. All right. Oh boy. I'm not sure I feel prepared for this one. Oh man. Okay. I don't even know if I want to try to solve it this same way. I think using regular expressions like this seems like the way to go, I would say. Whoops. Right, so we're kind of doing it in like these 5 steps, basically. And this one itself has several steps inside of it. So kind of break it up that way. So we have this regex, this one, then this one, then this one, and then we just trim join and uppercase. So, I mean, I guess, yeah, it's not a lot. I ended up with kind of a lot in this regular expression. Yeah, kind of a lot, kind of a lot. And honestly, there are probably still edge cases that I haven't figured out. So for example, what if, so it said you're supposed to handle underscore emphasis. What if you have stars for emphasis, right? Finally, some good food, right? So I didn't get the G there. I missed the G. So really, I think that a star should probably be included amongst these special cases. And then there's that. Finally, some good food. Yeah, but yeah, regardless, I don't know how to do any of this in Haskell. No! Okay, so it's basically saying that we should be able to use regular expressions. So we could try the PCRE. We know we have that installed, I think. So I guess we import text regex, and then is this PCRE? Or is it, well, it's something. I don't know what it is. I've already been here a while. The Haskell install kind of took a while. And then I did my basic solution in everyone's favorite soy dev language, JavaScript, and I'm okay with that. But like, yeah. For this one, I'm not sure I feel like I even know how to get started. Okay. What's in the file? Okay, so abbreviate string to string, and so we get a string come in, and we're like, you need to implement this function. Yeah, yeah. So it does say import. Okay, let's put these imports in there, maybe. Nope, not that. Did I not copy that? Oh, I didn't. There we go. Is that okay? Parse error on input module. Does module have to go before? Okay. Add text to your list of dependencies in package YAML. Okay, let's take a look. Dependencies. Text. Oops. So if we run test, it says could not load module data.txt. It is a member of the hidden package text 1250. Oh, cabal file. Okay, so this is generated from package YAML, and the text is in there. But what it said was add text to the build depends in your cabal file. Well, it is in the build depends, so maybe that's not it. Use -v to see a list of the files searched for. Okay, so let's do stack test -v. Oh gosh. Okay. Okay, so we tried the import, could not load. Perhaps you need to add text to the build depends in your cabal file. Okay. Which I think is here, text. So, and that's the cabal file, right? That's the acronym cabal. Okay. And then, okay. Oh, goodness. This seems like kind of a lot. Let's see. So, could not load module data text. Yeah, I don't even know, man. I don't even know. Okay, so let's look up some Haskell package YAML. I don't know. How do we, what's, okay, yeah. Help me, help me. Okay, so HPAC can be used to generate cabal files. It isn't directly tied to stack. So here it said, add text to your list of dependencies in package YAML. So that's what I did, right? Dash text here at the end. Oh, wait, no, it probably needs to be here, actually. Okay. It probably needs to be here. Okay, so is that better? Yeah, okay, so it failed the test suite. It says you need to implement this function. Okay, okay, excellent. Oh man. Okay, so and we can make it text text and refer to data text combinators. Okay. And the combinators are, okay. Wait. Okay. Ah, there might be some useful things here. So like breaking strings. So we can break strings by, I don't know, different ways, I guess. We can use like predicates. Some of this is gonna be what I end up having to do. I think this is gonna take me a long time. Unfortunately. We can do searching. Characters that satisfy the predicate. Oh man. We can index. So if you think of a text value as an array of char values, which it is not, you run the risk of writing inefficient code. I'm not too worried about that right now. Um, Low-level operations, I don't think I'm going to need those. Orphan instances. Hmm. Is, okay, monoid semigroup is list. Types, okay. Convert a string into a text is pack. Adds a character to the front of a text. Okay. Requires copying a new array. Huh. Adds a character to the end of a text. Append one text to another. Return the first character and the rest of a text. Or nothing if empty. Return all but the last character and the last character of a text, or nothing if empty. Return the first character of a text, which must be non-empty. Partial function considering using uncons instead. Okay. Return all characters at, okay, so uncons instead of tail. Test whether it's empty or not. Okay. Return the number of characters. Transformation. I am not angry. Okay, sure. Intercalate. Okay. Intersperse. Transpose. Oh, goodness. Reverse, replace. Okay. Okay, so I think that this can be done using replace to find whatever we need to get rid of and replace it with nothing. So, oh, my console is gone, but it was like this, right? So here I matched just the first characters that I wanted to keep. But if we're doing replace, then I think we want to find all of the characters other than the first characters that we want to keep. We want to replace those with nothing. And then in the end, we can probably do a transformation to change the lowercase to uppercase, I guess. I think it's going to take me a while. So we can do 2 upper. Okay, cool. Um, I feel like if we use this to title, that might get us part of the way there. I think it would mess us up on the HTML one, though. Because I think it would, I think that this T would turn to lower, and then it wouldn't end up as part of the acronym. What we could do, though, is maybe just insert a space first, wherever we find this, wherever we find a capital letter that follows a lowercase, then do to title, and then replace all the lowercase letters with nothing. Let me write this down. It's just a thought for how we might try to proceed. So, 1 would be add a space before any capital letter that directly follows a lowercase letter. 2 would be title case. 3 would be replace all lowercase letters with nothing. And then I guess 4 would be remove all spaces. So it says the first letter of the input is converted to title case, as is every subsequent letter that immediately follows a non-letter. So that's not going to work for several of these because we have like these ones like the apostrophe. I think the apostrophe is maybe kind of a special case. Because if we have a dash or an underscore or a star, then we want to treat the next letter as a letter that's part of the acronym. But if we have an apostrophe, then I guess we don't. Another thing, like, I think none of the examples include like quotation marks. So if we look again at the test, I don't think there are any examples that have any sort of quotation marks in them. So that would be another thing to consider, but I'm not gonna, they're not in the test, so I'm not gonna worry about it. Okay, I'm gonna come back in a couple minutes. BRB. BRB. So part of it is going to be we want to probably replace all any place that we have an apostrophe, we want to replace that with nothing before we add a space before any capital letter. All right, so let's try it. So the first thing we're going to do, let's try step 1. Okay, so which is so let's make this text like it said, and let's make this text. And then let's not do this. Let's go ahead and just try it replacing any apostrophe with nothing. So we saw replace in here, I believe. Okay, so replace. So we're going to search for a needle, which is going to be an apostrophe. Okay, so I'm going to say replace apostrophe, and we're going to replace it with nothing. Okay, let's just try that much. It says, okay, variable is not in scope. Okay. I was wondering about that, and now I know. Let's try again. Okay, so, couldn't match type char with text, expected text, actual string. Okay, so why is that? Let's see if there's something about that here. Empty. So if that string is empty, an error will occur. But what about this one? I want this one to be empty. T dot empty. Okay, yeah, let's do T dot empty instead, maybe. Whoops. Oh gosh. Oh gosh. What did I do? It says, okay, so this again is string. So we need creation, which is pack. So we'll go T dot pack, I think. Is it like this? I don't know. Oh, shoot. There's a hint. couldn't match expected type. Wait, I'm not sure. Hold on. It says, okay. Okay, so t dot replace is applied to too few arguments. Close this for now. Okay. Replace. Okay. So they showed replace oo, foo, oo. Oh, wait. We have to pass in the haystack itself, I guess. Okay, let's try it. Is that it? Okay. So expected ping, but got portable network graphics. So let's go into the tests and let's enable the test that has an apostrophe in it, which is this one. Okay, so where do we enable the tests? So cases. Okay, so ping. Wait, so maybe it only did up to the first failed test case. Is that what has happened here? Description input expected. Interesting. I think it only did up to the first failed test case. So I want to move Halley's Comet up to the start. I want this to be the first one. Okay, cool. So we did manage to replace the apostrophe. Now we're cooking. Okay, so add a space before any capital letter. Okay, so I'm just gonna change that test case for my own convenience. Okay, Halley's Comet JavaScript. Okay, so my next step is add a space before any capital letter that directly follows a lowercase letter. Okay, so we want to search for any capital letter that directly follows a lowercase letter. Okay, so let's see how this is going to happen. We can do a fold. That's not going to help me, I don't think. A special fold, so we can do a concat map. Neat. We can do an any. We can do an all. Maximum, minimum is ASCII. We can do scan. We can do accumulating map. All of it. Okay. We can do a replicate. We can do a take. We can do drop, take while, We can do strip. We can do split at, break on. We can do so we can do split on. I don't think this is gonna work for me. I think I need to do a regex, honestly. I think that's by far the most straightforward way. Okay, so let's see. Haskell regex getting started. Okay, regular expression tutorial. Yes, please. Okay. Asking how to use regular expressions. So yeah, in the languages like Perl, Python, and Java, this is a completely straightforward question to answer, but perhaps not so much in Haskell. All right, so we can do text regex posix. All right. So do we have to? Okay, yeah, let's do it. Let's do exactly what he's saying. GHCI. GHCI. Cool. All right. So I guess we're good here. So now we use mod command to load it and bring it into scope. Okay, so we do :m and we do plus text regex posix. Is that it? Could not find module. It is not a module in the current program or in any known package. Okay, so now what do we do? Okay, let's look at a different one. 15 years ago? Well, maybe it still works today, baby. Oh gosh, it just links to this same thing. This is from 2007. All right, all right. Okay. A cheat sheet? Yeah, sure. Let's see a cheat sheet. Okay, so we want to add, and this time it's TDFA apparently. Okay, so first of all, if I do plus text regex, I don't know what TDFA even is. TDFA, okay, so we can't find it. So let's close out here. How do I exit GHCI? No. All right, wow, that's a lot, actually. Quit? Okay. All right, so in our package, let's add a dependency, I guess, and this will be regex TDFA. Why TDFA and not another one? Okay, that sounds nice. Oh, dang. Okay, cool. All right, let's go for it. I had no idea what it probably even stood for. Okay, so where were we? Okay, TDFA text. Okay, so we do that. I think some part of this adds that to our cabal, I believe. Is that what it's doing now? Goodness, what a lot of cabal files. That's crazy. Whoa. Does that seem like a lot of cabal files? Am I crazy? Is this gonna screw me over? I don't know. Maybe it's okay. Maybe it's fine. It just keeps going. It seems wrong. Is this... No, what is it doing? Why? How can we process this many Cabal files? Do I need to stop it? I have no idea if I need to stop it. Okay. No version is in the stack configuration. That was crazy. That was completely wild. Try adding the following to your extra depths. Oh. Well, sure, I can add it, I guess. Wow. I think this might be better as like this. Okay, let's see what it does now. Okay, cool. I'll give it a shot. Failed to construct a build plan. Allow newer depths. Okay, so where does allow newer depths go? This is in config. Oh gosh. Okay, so I'm gonna say allow newer depths, I guess. Let's, oh gosh. Is that what it said? Allow newer depths, regex space. I mean, sure, I'll try it. Okay, so I did this. Allow newer depths, regex space. Okay, so then let's try this one. Allow newer, true. Okay, let's try allow newer, true. Okay, so I have allow. Okay, so then let's add regex tdfa. I don't. It's running me around a little bit. That's crazy. Okay. Bang pattern in expression context. Well, I don't know what to do about that. I've never tried Haskell before. I don't know what to do about that. Okay, so I think the thing to do is to try a different regex, right? Because it explained that there are a whole bunch of options. So we tried TDFA. It sounds cool, whatever, but it didn't work. So let's see if we can do PCRE maybe. That would be nice. And all this about TDFA, I'll get rid of it. Okay. What's it say now, baby? Oh gosh. Oh gosh. So try adding uh both these. Okay, so let's do regex base. I've already got one for that though, so all right. Okay. And then this one is PCRE text. Okay, cool. It says add these. Oh gosh. All right, here we go. Oh my goodness gracious. Okay, it says same. Okay, yeah. Allow newer depths byte string. This is a big skill issue. It's running me around in circles and I don't know what to do about it. Okay, so now I have regex base again. Okay, so I have text. This is not the way to go. I'm sure this can't be the way to go. Okay, binary, maybe this is the last one. Who knows? Who knows? It says, oh gosh, oh gosh. Oh no, no, we already have base and text. Okay, okay, okay. This is gonna mess me up. Okay. Okay. So I want to like not do any of this. So let's get rid of both these. And let's get rid of all of these. Okay, let's try. Okay, so it says, oh, okay. So that reverted it. That reverted it. Okay, let's look again for, okay, Haskell regex getting started guide. Let's look for a different one. Okay, so Serpentine. So it said add dependencies, regex TDFA, and regex TDFA text. Oh man. Full circle, it seems like. Okay, maybe I did it wrong before. Let's try it here, I guess. Okay, so these were added as dependencies, it looks like. Regex TDFA text. Okay, I guess so. And then in our source file, do we want to import these? That's what it says, right? So let's try. Nope, not that. Yeah? Okay, what does it say? Could not find module. Okay, let's see what happens when we run this. It said, oh gosh. I'm hesitant to go down that road again because it didn't work before. Um, okay, so does it say what to do if we run into trouble? Okay, so this cheat sheet is now part of the documentation. Um, oh wait, no, this isn't, hold on. Yeah, let's do this. Or try to. Okay. Someone showed up on Haskell yesterday asking how to use regular expressions. This isn't a completely straightforward question to answer. As I am learning. Okay, so while Haskell's regex libraries provide the same functionality you'll find in Perl, Python, and Java, they provide a rich and fairly abstract interface that can be daunting to newcomers. So let's fix that and strip away the abstractions to show how we might actually use regexps in practice. I'm assuming that you're already familiar with regexps from using them in some other language and simply want to find your feet in Haskell. Yes, that is a correct assumption, baby. All right, so the standard library that implements regexps is text regex posix. Okay, so let's link over to here. Oh gosh. Okay, text regex posix. So I believe what we want to do is maybe go into our package. All right. And just say posix. Get rid of that one maybe for now. And then what does this say? Well, this doesn't look so bad. Okay, so now let's go into our source again. And we'll get rid of those. And it says, okay, wonderful. So now if I do what this guy suggests and go GHCI and go :m plus text regex posix, that's what it says here, right? Then it says could not find module. Not a module in the current program or in any known package. Well then. Wild. Okay, well, interesting. Okay. So where did we go? So this wraps the system's native POSIX extended regex library. All right, sure. Let's see. If you're coming from a language like Perl, Python, or Java, you may not have encountered POSIX regular expressions before. Perl-style regexps are much more expressive and hence far more widely used. POSIX regexps look superficially similar to Perl-style regexps, but they're not as expressive and they have different matching behavior. There aren't any concise online descriptions of the syntactic and semantic differences between the two regexp families, but the Wikipedia entry on regexps will help you to understand some of the differences. I think this regular expressions.info is an incredible website with far more information than anywhere else, I think. I mean, I don't know, but there's a lot here. So if in the reference, I think there is something that is like all about POSIX versus Perl, probably. Oh yeah, POSIX. But regardless, that's not the main point right now. Okay, so the only advantage of the POSIX regex library is that it's bundled with GHC. You don't need to fetch any extra bits to get it to work. Okay, so hence why they said that we could just do this, but it's not working for me yet. We're gonna figure it out, baby. We're gonna figure it out. All right. So it was explained here. Regex POSIX. These are very slow. Well, that's lame. Um, so, okay, all are available from Hackage as TarGZ sources. Can we do, okay, can we go mod plus text regex base? Can we do that? No. Darn. Oh, man. Leaks memory in some cases? Darn you. Man, shoot. I've been at it a while. You know, at least it's not like that frickin' Faro small talk. I'm still mad at it because like I'm pretty much well over an hour in here with this Haskell, but with Faro small talk, I was well over an hour in before I even figured out how to run the hello world. And that was annoying. This is not annoying in that same way, but it is taking a long time, that's for sure. Yes, I'm just very clueless. Satisfying Haskell dependencies. How not to use stack install to manage dependencies in Haskell. You almost certainly do not want to use stack install. Cabal install? Oh. Okay, well, what if I do that? Cabal install the package. Is that how it has to be? Okay, so we couldn't find text regex POSIX. So, what if quit? So what if we go cabal install install, there we go. Lib regex, and then what one were they saying here? POSIX? Okay, so that's the slow one, right? If we're gonna install one, let's do PCRE, that's what I want. Okay, so then what does it say if I do this? Could not resolve dependencies. Lib PCRE any. Can we do regex base? Cabal install lib regex base? I feel like I'm going crazy a little bit here. Oh, well that seems okay. So does if I have done that, does it mean that I should now be able to do text regex base? Or actually it was a plus, right? Oh, so I guess it's fine now. Is that it? Okay. Great. Great, great. I'm a little worried though, because like if I do this and then I submit it to exercism, I am not sure. I am not at all sure whether that is going to be okay. Um, because I'm going to send my source file, but if they're like, oh, it's not going to work because we don't have these dependencies, then I'm going to be annoyed. So I'm going to step outside and think for a second. Basically, my thought process right now is that I probably just need to avoid using regex for this because it just seems like I'm not confident that I'm gonna make them work. So that if I'm not gonna use regex, then I need to think of the way that I'm going to find a capital letter that directly follows a lowercase letter. So let me just look. So we can do predicates, view patterns, searching. Okay, so we can use a predicate to find a character that is a lowercase character, I guess. Let's see, searching. Oh, yeah. So, like, we could use something like this, break on all, I guess. So then if we were to break on all lowercase letters, no, that doesn't seem right. We could, shoot. Okay, so I think it's just gonna be a simple recursive thing where we go through the text, probably using this, let's see, add a character. No, this one on the cons. So we'll just go through each one, the first character, and then I'm just gonna need to look at char and then see what is the way to tell if it's an uppercase or a lowercase. Oh, is lower and is upper. Okay, so that's great. So that's what I'm gonna do. I am gonna step outside for a sec to think about it and reset my brain. I'm sure that using regex fin Haskell is probably wonderful once you've got it going. I'm not confident that I can get it going for this one though. Okay. All right, let's see. Okay, so let's actually get into it. This whole thing has been a mess, but let's actually get into it. So if we go into the source, yeah, so this is the first thing we want to do. And then we want to do this next step, which is going to be add a space before capital. So, add space before capital is going to be text to text. And then add space before capital, we're going to take uncons. Where is that? Yeah. Oh, where's my music? Oh, it's just quiet. Okay. We're gonna take an uncons to get a char, a maybe, char, and text. So I guess we have to match one case where we get an empty. So if we get an empty, then we just return an empty, right? Okay, so that's one case. I don't, I'm imagining something like the syntax that I saw in standard ML, and I don't know if I'm at all right. Okay, I think I'm going to close the ones that have to do with regular expressions, because I don't think I want to use those. Oh, what was that one I just closed? William Yale. Regular expression, regex. Let's not worry about that one. Let's not worry about that one. Or that one, or that one. Okay, yeah, we need this. Okay, so where's the Haskell? Okay, so learn UA Haskell. Let's take a look. So, baby's first functions. Sure. Okay, so something like this. All right, so then what if we... Okay, so we have if, then else. So we could try that. Intro to lists. Okay, cool. Texas ranges. This seems like really good info. I'm just wondering if there's like a matching thing that we do. Types, pattern matching. Yeah, let's take a look. Ah, okay, yeah. Okay, perfect. This is exactly what I hoped. Okay, great. Great, great, great. So, we have the case where it's empty. Great. Now, the next case is... Okay, so what about the maybe? Because if we do uncons, we get the maybe, right? Maybe char text. So if we have a maybe, then we might get something, or we might get nothing. Okay, cool. So we need to handle the maybe. Go back. Maybe char text and give back text, right? Add space before capital helper, I guess. And that takes a maybe char text and gives back text, right? Yeah, I think so. And so in the case that we get nothing, then we'll just go empty. Right? Yeah, that makes sense to me right now. Because that's what it's saying, right? Maybe could be nothing. Okay. Okay. Then, if it is not, then we get a C and a T. And in that case, then we need to see, we need to see if it is capital or not. Am I going to do another? I'm doing this in a very verbose way, and that's just based on inexperience. All right. If I go through this whole book, I will know a lot more. But for now, I'm going to say we're going to check is lower. Oh, here's what let's do. Let's say if is lower, and is lower comes from char. Okay, so I'm going to say import qualified data.char as C. I don't know if that's the way to go. But I'm going to say if C dot is lower, C, and then we go then. I just wanted to, I saw that. I think it's if then. Was it then? Is it okay, else? Yeah, if then else. Okay. So if it's lower, then and okay, so char is lower, we get a bool. Okay. So if is lower C, then we will add the capital. So this add space if capital takes text and gives back text. Okay. So then, oh, I don't even have my uncons yet. T dot uncons. I don't even know why they call it uncons. So I think this should be more like that, right? Uncons XS. Okay, so add space if capital. Okay, so again, or no, we want t dot empty equals t dot empty, I think. And then man, I think I have to uncons this one as well, probably. Okay. Okay, is that it? Add space if capital. And then else. Okay, so if c dot is lower, then sure, else, okay, t. Yeah? No. T dot uncons t. Okay, so is upper C, then else. Okay. All right, so now what does this say? Okay, so qualified name in binding position t dot empty. Okay, wait a minute. Qualified name in binding position t dot empty. So we can create the empty text like this, but we need a way to check if it is empty. Okay. Empty. Null. Test whether a text is empty or not. Okay. So here, what we really want to say is probably get rid of this. And then here say if t dot null xs, then t dot empty else. right? And so similarly here, we want to go if t dot null, no. Okay, no, this one should be nothing. Maybe. Okay, so now what does it say? It says couldn't match expected type maybe char text with actual type char text. Okay. So when we do maybe, okay, so we have wait a minute. Oh, we do just? Okay, it said that before and I didn't get it. Okay. Okay, so nothing F. So now it says different numbers of arguments. Okay, so we have nothing. Oh, wait. Okay, hold on. Experimenting, I guess, a little bit. I don't know if any of this is right. Okay. Oh yeah, I think this is a little bit better. So we say couldn't match expected type text with actual type char string. Okay. Okay, cool. So here we want to put this, I believe, and likewise here. Yeah, probably so. And then we want to go t.pack. Okay, so now it says couldn't match expected type char with actual type text. Oh, interesting, interesting. So in the data text, can we plus this? No. Haskell text concatenate. I think we probably have to turn it to, oh, huh. Okay, okay. Let's see, let's see. Hmm. Somehow I don't think this is gonna work. It wouldn't, would it? Okay, so t dot pack. Okay, so couldn't match. Okay, so expected string actual text in the second argument. So do I have to pack? Okay, I was thinking I might. So be it, I suppose. This is seeming crazy. Okay, so now it says couldn't match. Okay, hold on. Couldn't match type text with char. Expected string actual text in the first argument of this. And so what is it supposed to do? Text 1 and text 2? Hmm. Just use mconcat, this person says. Yeah. Okay, well, let's do that then. Yeah, this looks good to me. Looks nice. Okay, so it's pretty much, okay, it's going to be completely different. We're going to say then mconcat, and we're going to put that, and then C, and then we're going to put T, I guess. And this one is mconcat CT. I don't know. I don't think that's quite right, but let's see. So it says cannot match expected type text with actual type char. So is it different if we do that? No. Okay, so now what if I do packet? Now it says couldn't match type. Okay. Now it says, okay, cool. Halley's Comet JavaScript, amazing. Okay, so then what are these? Okay, defined but not used. Oh, wait, they should have been used. Oh, wait. Okay, let's keep going. All right. So abbreviate, okay. Replace. So now this is going to be add space before capital on this whole expression, I guess. Let's see what happens. Oh no! Oh no! Oh no, I got rid of the HA. Okay, well that's crazy and very dumb. Very dumb. Okay. Okay, so then this becomes this. And we do m concat here. And we do t dot pack c. And then here we do m, oh gosh, m concat t dot pack c. Okay, so then we shouldn't lose the c's. Okay, so I still have Halley's Comet JavaScript. All right, so now add space before. Okay, so if it was nothing, then we get t dot empty. So then here we're supposed to add space. So if it is lower, then we add space if capital. Okay, so then here, whenever we have this t, we need to call the add space before capital helper again, I believe. And likewise here. Adds. Yeah. Oops. And now it says, yay! Okay, so that's one step done. Add space before any capital letter that directly follows a lowercase letter. Okay, so then the next step is to title case. So let's go into the tests again. And I'm going to just add some more here that just says something fixed up beyond all recognition. So these are all lowercase. So now when we run the test, it still shows that. So now we want to title case this. Okay, so that is going to be here. We are going to say, no, is it here? It's here. So after this has happened, oh, can we use piping in Haskell? Haskell pipe. think it should be in here somewhere, probably. Let's see. Table of contents, functions, composition. So if we do dot, okay. So that means we would, let's see. I'm not going to worry about that right now. I think I'm okay with just doing this. So we're going to add another one, which is going to be title case. So we're going to go t dot title. Where is that? To title on all of this. Okay, let's run it. Amazing. Okay, so now replace all lowercase letters with nothing. Let's do it. Getting close now, I think. T dot replace. Shoot. I think I'm gonna have to roll this again. Unless... like, it needs to take a predicate or something. If we can replace using a predicate, that'll be perfect, but I don't think we have that option here listed. Okay, it's fine. So it's going to be replace, or let's just say remove lowercase. And that's going to take a text and give back a text. Okay. Remove lowercase xs if null xs, then t empty, else remove lowercase helper t uncons xs. Okay, so then remove lower. I am sure that people who are not bad at this can, I'm almost certain, probably do this in so much less code. But whatever, I'm just gonna get through it, I guess. So this is gonna take a maybe char text and give back a text. Very fun. And so if we get nothing, we'll give back empty. If we get just CT, then if C dot is lower C, then we will remove lowercase helper and pass in t dot uncons t. All right. Else remove else it's going to be m concat t dot pack c remove lowercase helper t dot uncons t. And I believe that's it. let's, okay, so then that means that here we will put in, oops, remove lowercase, well, remove lowercase, I mean, on all this. Okay. Ah! We are close. And the last step is remove all spaces. Amazing. I'm actually super happy about this. This is so verbose, but I am super happy regardless. Okay, so um oh, I was gonna change the test because the test isn't right anymore. So this should be foobar. Okay, so then the last step is to remove all spaces. Okay, so that's going to be another one, I guess. So it's going to be, whoops. Remove all spaces. Takes a text and gives back a text. Remove all spaces XS if null XS, then T empty, else remove all spaces helper, T uncons XS, okay. And then this will be, okay, hold on. So then this will be remove all spaces helper. It takes a maybe char text, gives back a text. Remove all spaces helper, XS, if, or no, excuse me, we'll do nothing, empty, and then remove all spaces helper, just CT equals if. Okay, so then we just want to say if it's equal to space, right? I'll just say is space, why not? Yeah, that's cool. Is space, and then we'll say then remove all spaces helper, T uncons T, else mconcat T pack C, remove all spaces helper, T uncons T. And that's it, baby. Okay, wait. Oh, I put something. Okay. Typo. That's just a typo. All right, here we go. Oh, it didn't work. Dang. Oh, I didn't call on it yet. I don't think. Yeah, we have to call on it here. Remove all spaces. Okay. All right. All right, we are getting closer now. So, it's, let's see, 4 examples, 1 failure. So we didn't get HTML correct. Interesting. Okay, let me look. So apparently we were, okay, hold on. I want to look at the test. Okay, so JavaScript I thought was okay, but HTML not so much. Ah, interesting. So why? Okay, okay. So for HTML, it is different because it's the first word. So could it be that I screwed it up because it's the first word? I was supposed to add a space before the word text, but apparently I didn't do that. It says, yeah, so HTML and but got HML. Okay, so I'm just going to look at it and see if I can discover any reason that it would not add a space if it's in the first word. Okay, so we replace the apostrophe with empty. And then we're supposed to add a space before capital. Wait. Add space if capital. Okay, so if it is lower, okay. Haskell print debugging. I don't know. This is so ugly. Okay, so where do we trace here? Trace here. Okay. Okay, let's see. So we remove all spaces, remove lowercase, title, add space before capital. Well, okay, let me just check a couple things. So if I am in the test and we put hypertext here, there's not anything wrong with the word hypertext, is there? I don't think so, but let me just confirm. Apparently there is. Okay, never mind. Hypertext. I have JavaScript, and we got that, but hypertext, I did not. Oh, that's wild. Okay, so let's go into our GHCI, and can we do m plus whatever it is? Hold on. GHC. Okay, so can we import our data.text? Set package text to expose it. Okay, let's try. Set package text. Okay. Okay. So now that's crazy. And then let's do data.char. Okay. I'm definitely barking up the wrong tree now. Doesn't make sense at all. Okay. I've definitely made some silly error in logic here. So add space before capital. We go to the add space before capital helper. Okay. Then we do add space if capital. Then we do add space before capital helper either way. Somewhere it's not working right. Okay, if is upper C. Then we put the space in there. Man, I was so excited when this seemed to be working. It only worked on the word JavaScript. I mean, is it going to work on any other words? Like if I put some other word in here, like, I don't know. So if it's like Pokemon like that, then it should be EN, I believe. Okay, again, we dropped the P. So why did JavaScript seemingly work? And JavaScript still appears to work now. That is crazy. I'm freaking out. Okay, so add space if capital. If C dot is upper C, then put this in here. Oh man, I'm really confused. I'm really confused. Okay. Yeah, I thought it worked on JavaScript. Okay, so let's see. So let me, how do we comment in Haskell? Haskell comment. It's in this book, right? Let's just contents. Comment. Oh shoot. Okay. All right, let's see here. So I am going to delete this. Okay. Halley's comment. Okay, so it did not put the space in there, but it did put it into JavaScript, but it did not put it into hypertext. That's wild. Okay. Yeah, I don't know. I don't quite know what I've done wrong here. Pokemon. Okay. It did put it into JavaScript. Okay, if I have JavaScript again at the start, will it put it in there? JavaScript. And then what if I put JavaScript in at the end as well? And then this would be JS, and then this would be JS. Okay, so it does split JavaScript all 3 times, but it doesn't split Pokemon, and it doesn't split hypertext. I do not know what to think. Okay. What if I just have AS like this? Okay, so it split those. So the S that followed the A worked fine, but not the M that followed the E. What is going on? Yeah, I'm really okay. So A followed by S got split as it was supposed to. So could there be something wrong with, so we're, okay. Do I need to say is lowercase instead? It says is lower is legacy. So sure, let's make that change. And hey, maybe if I'm lucky, maybe that'll fix it. So I have is lower, but we want is lowercase and is uppercase. Okay. Not in scope, c dot is lowercase, data dot char does not export is lowercase. How can this be? No. Okay, so it says since base 4.18.0.0. Okay, let me try and update my Haskell. Okay, Haskell update. Man, I've been at this a while. It was GHC up, right? Okay, GHC version 948. Okay, And then can we update it to the latest version? Okay, here we go. GHCP install GHC 9.10.1. Yeah. Okay. So I think I need to go into interactive mode and mess around with my functions a bit. Installing GHC again. I don't feel like this is the answer though. All right. I am going to come back in a few minutes, a couple minutes, just real quick. All right. Well, I am not surprised to find I ended up spending a lot of time on this hassle. Okay, so let's go GHCI source. Yeah, like this. Okay, so, oh, interesting. Um, huh. I'm actually a little bit annoyed at this. This in particular, like, come on, don't do me this way. That's crazy. Um, so let's see. So GHCI help. So when we run it, we can do a command line option. Okay. So GHCI dash I dot so let's see, so the directory goes here. So it's just this directory. Okay, and then source. Okay, so no good. Search for imported modules in the directory. Okay. GHCI show options. Okay. Yeah, it is a lot. Let's see if, do I know what I think it might be? So set package. So we can do I don't know. Oh man. Oh man. Okay, I'm losing it. I am losing it. Okay, so we cannot use, so data char does not export is lowercase. Let's look this up. Presumably it's because it's an older version, right? Um, okay, but regardless, like it's crazy the idea that data.char would not correctly identify lower and uppercase on just simple letters from ASCII, right? Like that's crazy. What's the other one? Oh. So I mean I don't think that's the problem. I think it's some error in my logic, but it seems so odd. It seems so odd. Okay. So let's go into the test and let's do it. Let's do a different test. I mean, I guess this one is fine, but let me add another test in before. So case. This will be like this. And then okay, so here we'll say description equals space before upper. Input equals, okay, so I'm going to put AS, BV, RT, UJ, IM, OP, CC, QQ, RB, just to guess some, all right? And so then the expected is that we should come up with A, S, V, T, J, M, P, C, Q, B. And that's it. Okay, So it split the AS, it split the DV, it split the RT, it split the UJ, it split the IM, Wait! This is madness. So it actually did all of them correctly. Oh my gosh. Okay, so it did all of them correctly here. Okay. I'm getting increasingly nervous. Okay. So let me reactivate these for now. Oops. Oh my goodness. I don't know what to think. Okay. So it split everywhere that it was supposed to. A, S, V, T, J, M, P, C, Q, V. It split everywhere that it was supposed to. Okay, so now what if we put in this word Pokemon? Then we should get PM here. But Pokemon remains unsplit. I think that it is a problem with how many, like whether it's an even or an odd number of lowercase letters. Legitimately, I think that is what has happened, which is absurd. Like, I think that will do it. I think that will do it because they're odd numbers of lowercase letters. Is that crazy? That's really crazy, right? Yeah, it did. And so then if we go in here again, and if I go, I think that won't work. I think that won't work because they're even numbers of lowercase letters. Yep. Okay, so that exposes the logic error. Now let's fix it. So the trouble is that in a certain case, I'm making like the wrong recursive call or something. So we go add space before capital, and we find, okay, so it is lower, and so we do this, and we add space before capital, add space if capital, and then we come into here, and then we say, okay, so it's not upper. So then we come in here, we put that back on, and then we come back down to here, add space before capital helper. I'm almost seeing it. I have to write it out. I'm almost seeing it. I have to make a little chart for myself because I'm dumb. Okay. So when we get a lower case, we can't go back to add space before capital helper. We have to add space if capital, right? And that should fix it, actually. Okay, so now those are splitting correctly. Okay, well, that was a crazy, crazy thing. A really goofy oversight. Obvious, but it took me forever to see it. Obvious once you've seen it. Okay, so Abbreviate space before upper. So expected AS, VT, JMP, CQ, BPM. Okay, so I think that test is wrong. It should be OM, OM, PM, KM, PM. Is that it? Okay, FIFO. Okay, so we don't handle the comma correctly. We're keeping a comma. So I didn't have anything here for handling a comma. So when I go replace all lowercase letters with nothing, that should probably be and punctuation. Or actually, remove all spaces. It's probably just a separate step. Step 5, remove all punctuation. Okay, I'm actually moving forward again. This one, yeah, this one is forever crazy. All right, remove all punctuation. So, in data char, do we have something for punctuation? Because we have is control. Okay, don't want that. Space, upper, alpha. Okay, so if it's not alpha, then we don't want it. Okay, so remove non-alpha helper, and we'll take a maybe char text, remove non-alpha helper, nothing, empty. Just CT if is alpha. Wait. Okay. I think we should be okay. If is alpha, then M concat T pack C, remove non-alpha helper, uncons T, else remove non-alpha helper, T uncons T. Okay, and then we have to actually call it, which will be and it says, okay, so CMOS, abbreviate punctuation without white space. Okay, so what does it say on CMOS again? CMOS, it has a dash O. So we shouldn't really like, so, okay, so if it's a dash or an underscore or a star, those should all be replaced with spaces pretty like early on, before we title case. Before we title case, any kind of dash or underscore or star, yeah. So when we do matching, like, we can match, wait. what is it called? Cases or something? Oh, pattern matching. So when we pattern match, let's see. I think we can have a pattern where we just put some different things together, right? Okay, I'm just gonna, wait a minute, wait a minute. Yeah, I'm just gonna do them separately. I don't know. Okay, so, um, punctuation to space. Punctuation to space. We'll take a text and give back a text. Punctuation to space. If null, then empty. Else, punctuation to space helper, t unconst xs. This one takes a maybe, char text, gives back a text. If it's nothing, we'll go empty. Okay. If it is just a star, then we go mconcat tpack space and then punctuation to space helper unconst t. Okay. And then it's the same thing. Yeah, I'm sure there's a better way. But same thing for underscore and dash. And then for anything else, and then the rest of this is the same. Okay, so then we put punctuation to space in here somewhere when we make the call, which will be punctuation to space should be before title space, title case, I believe. That will be, all right. Okay, that's it. Man, that was a long one. That was a long one. That was windy, a lot of ins and outs all over the place. So now I I give it 50-50 whether it actually accepts it when I submit this to their server. I give it 50-50 maybe. In fact, actually, let me look at the help first. So okay, so let's take a look. So stack test, I think we're okay. Yeah, we did all that. Okay, submit. Okay, so it's asking to submit the package YAML as well. Okay, so that's exactly the kind of thing I was looking to know. So let's totally submit just like that. Okay. Crazy, crazy. All right, processing. That one was twists and turns all over the place. Okay, it does say failed. I'm not super surprised. All right, so let's see what the failure is. An error occurred. Regex POSIX. Okay, so there's something in there. I didn't end up using any regex, but I think it must still be in my package YAML. Yep, we need to get rid of that. Okay, let's run the... Oh, I meant to run the test. Let me run the test. Got a little too excited. Okay, so it says 11 examples, 0 failures. This one says passed. Okay. That's it, baby. That's Haskell. Yes. All right. This is so insanely verbose. There is no way I should have done this much code, and the reason I have this much is because I just don't know anything about Haskell. I mean, I know something about it now, I guess, just very little. I'm gonna mark as complete and go to the next one, baby. Oh, yes. I'm feeling pretty good. I'll probably go for at least like another hour here. So let's close all these Haskell things and let's see what's next on our menu. Okay. 48 and 24. It says, okay, so we got the Haskell completion, and next up is Tickle. Okay, I don't know anything about this one. Let's join the track. Practice mode, local machine. Let's install it. All right. The only tool you need is the Tickle interpreter, Tickle SH. Okay, so I'm gonna see if Homebrew will work. Oh, no. Brew Tickle SH. Okay, let's give it a shot. Okay, so I guess that's probably good. So now it says a program called RLWrap exists that adds readline functionality. Okay. Okay, so already installed and up to date. Okay, so we're good there, I guess. So now, let's see. It's so handy, you'll always want to use it. Add this to your bash RC. Okay. Okay. All right, sure. Let's give that a shot. It says 8, 6, 12. Okay, so let's do the hello world. It says result was goodbye Mars. Okay, cool. Not too shabby. It says passed. Okay, let's submit. Yeah, that one. Okay, so that one's good. Passed, so mark that as complete. Okay, let's just close that. All right, so now we're going to go back to acronym. If we can make regex work here, then it shouldn't be too hard. At all, right? Because again, in JavaScript, all I have to do is, well, actually, I don't know which of these is the latest. Probably whichever one has the star in it. Yeah, that would be the latest. So that's really it. That's all that needs to be done for acronym. So hopefully this won't be so bad. All right. Okay, so first things first, I want to know tickle regex. Yeah, this looks like it should be okay. Let's give it a shot. So we're gonna go tickle sh. All right, so here we are. And then let's just try what they did here and see what happens. Okay, cool. All right, in that case, let's try this regex that I was just using. Okay, so they put it in. Wait a minute. Okay, so okay, hold on. So we want a regex what? So we want to go all. Okay, so if we do that same thing, but we put all this time, then how much comes out? Probably a lot. Not SSL. Not SLL. All. It just puts 3. Total number of matches found. Okay. Can we do a replace? Ooh. Ah, sub. We can do a substitution. Ah, yeah. Oh, yeah. Okay, cool. Okay, so let's grab this example. Okay, so let's say string equals hello bar, hello bar. Oh, okay, can't read, okay. I'm gonna learn a little bit. Typical assignment. Assigning values to variables. We do set. Okay, interesting. So we'll say set string. Okay. All right, cool. That's neat. And then on sub, this is sub. Okay, so we'll try this. Oh, it said 0. So now if I put string, puts string. Okay, so that's what we want. Okay, so it didn't sub anything because we only had bars in there. So let me set string again and say hello foo, I guess. And then do this again. And then put string again. Oh no, okay. Replace in the string in variable string every instance of foo, which is a word by itself, with bar. Wait. Okay, no case, interesting. Replace in the string in variable string every instance of foo, which is a word by itself, with bar. Mm. Okay, so reg sub. Oh, I can't tell if anything is actually happening. So switches, expression, string, subspec. Okay, what if we do it without that at the end? Oh, huh. That's not cool. Okay, and what if we do exp and get rid of this? Then it says 0. So it doesn't, so it didn't actually match. Right? Interesting. Did I misspell something? Interesting. No, I think that's okay. Okay, so it just doesn't think it matches. Okay. Hold on. Okay, no good. Oh man. So this first one did work, right? So in that case, nothing comes back. Okay, so we can match it this way. I still feel like I have a decent amount of energy, but I think I'm actually gonna have to stop and come back later this evening at this point. There's some other things I gotta look into today. Okay, I only finished one so far, and it took forever. Okay, I'm gonna call it good. I'm gonna come back for more later. I'm gonna stop. So long.